So, good afternoon, everybody in Brazil and in the US. Good evening in Europe. Good late night or morning elsewhere in the world. Welcome to this fourth and last webinar, Reflections on Wood, of our Future Now webinar series. Welcome also to the participants from ArcDaily, World Architects, the American Institute of Architecture, and the Núcleo da Madeira. First, I would like to explain how you can choose your language for the webinar. Go to the box with the globe at the bottom. On click, you can choose for English or Portuguese simultaneous translation. Em português, você pode clicar no box com o ícone do globo embaixo. Lá, faça a sua escolha para tradução simultânea para o português ou inglês. Questions to the panelists you can write in the Q&A box, also at the bottom. The panelists will answer to a few in the last part of the webinar. For interaction with other participants, please use the chat box. Don't hesitate to put there your name and a link to your LinkedIn profile if you'd like to connect with other industry professionals. So let me quickly introduce Inside Architecture and the project Future Now Pavilion, as it is the context of this webinar. Inside Architecture aims to convey knowledge for contemporary and modern architecture in Latin America, with a focus on Brazil. We offer architectural travels, conduct conferences and events, and create exhibitions for a local and a global audience. A project we were developing for over 2 years and comes now to fruition is the so-called Future Now Pavilion. It is an exhibition that is the official Swiss contribution to the 27th World Congress of Architects, UIA 2021 Rio. Open until this Sunday, October 17th, at the popular Mauá Square in the center of Rio de Janeiro, next to the Museum of Tomorrow and the Museum of Art of Rio. We built a new architectural experience with the open-air exhibition Future Now, Revisiting Earthen Architecture. The complementary exhibition is about innovation within the construction techniques of rammed earth, also called pisé, or taipa in Brazil, and digital fabrication with clay. The project is one of the few physical exhibitions that is part of the UIA Congress. The initiative was developed in partnership with the architects Diego Baloyan from Chile and Pedro Rivera from Brazil, in collaboration with the Swiss Federal Institute of Technology, ETH Zurich, and with support from Pro Helvetia, Zürcher and the General Swiss Consulate in Rio de Janeiro. The exhibition is curated by Inside Architecture and its content realized in partnership with the ETH by the two chairs of Gramazio Kohler Research and Studio Bolzhauser. As a pure wood construction, the pavilion is built by Ita Engenharia, a Brazilian construction company working exclusively with locally grown reforested wood. And the pavilion is designed by Diego Baloyan, Sebastián Silva, Matias Baeza, and Juan Pablo Perot, and it is fully reusable and recyclable. The carbon footprint of this event is fully offset by the carbon-saving projects of My Climate. So why this exhibition? Clay is one of the oldest known building materials and is available in large quantities all over the world. In the course of history, technological development has steadily reduced its significance by first introducing fire clay and later by cement and concrete. The widespread of this very performative and supposedly eternal material was enabled by the almost limitless availability of cheap oil and coal-based energy throughout the 20th century. Now, climate change and the threat it poses to nature and civilization is forcing us to reduce the amount of embodied energy in building materials and thus to radically rethink the way we build our environment. It is from this perspective that Future Now intends to revisit the potential of unfired clay as a fully reusable carbon-neutral building material, and which has the added advantage of not needing far transportation as it can be sourced locally worldwide. Studio Bolzhauser and Gramazio Color Research have investigated the potential of clay constructions for a more sustainable future. Displayed at the exhibition alongside highlights of the rich cultural history of earthen architecture are two prototype lighthouse projects that were developed together with students and researchers. We must recognize that nothing is for eternity and that the built environment needs constant maintenance and transformation. This simple finding makes it imperative to build more and more with zero waste and carbon-neutral materials, and to look for a radically contemporary architectural expression. Future now, o futuro é agora. As part of the parallel event to the UIA Congress, Inside Architecture also produces, in collaboration with Swissnex in Brazil, webinars on architectural and technological developments for the future. For this webinar, Reflections on Wood, Flexible Systems and Wooden Constructions for Challenging Environments, we invited the two architects, Josep Ferrando from Spain and Marcos Acayaba from Brazil. Barcelona-based architect Josep Ferrando is part craftsman and part academic, Dean of the School of Architecture La Salle in Barcelona. His work has also been shown in various countries, and he has had monographic exhibitions of his work at the Venice Architectural Biennial and the Museum of Modern Art in Rio de Janeiro and in many places elsewhere. Marcos Acayaba from São Paulo graduated from the FAU USP in São Paulo, where he taught also from 1972 to 1976 and also since 1994. After his first phase, inspired by Oscar Niemeyer's freeform and the use of exposed concrete, he began also to use industrialized systems, precast concrete, metallic structures, and industrialized wood components. The moderator today is John Hill. He has over 10 years of architectural experience in Chicago and New York, and does programming also that promotes architecture, design, and the built environment. He lives in New York City and is the chief editor of World Architects of the PSA publishers. Now I would like to give the panel to Gabriela. Gabriela Devaux is an architect from the ETH Zurich and project manager at Swissnex in Brazil. Swissnex is the Swiss global network connecting Switzerland and the world in education, research, and innovation. And we are collaborating for this webinar series, Future Now.
Hi, Jason. Thank you, and congratulations on the initiative of this event series and the beautiful exhibition in Rio de Janeiro. The team of Swissnex in Brazil is happy to be part of this series of webinar, which is an excellent platform to foster dialogue between architects, researchers, innovators, and the audience from Brazil, Switzerland, and all over the world. I'm happy to see that people are joining from every part of the world. Welcome, everyone. I hope you will enjoy the discussion today with these great architects. So on behalf of Swissnex in Brazil, thank you, Marcos, Giuseppe, and John. I wish you an excellent discussion today and hope our audience also takes part of this dialogue by participating and sending questions in the Q&A and networking in the chat box. Now back to you, Jason. Enjoy, everyone.
Thank you, Gabriela. So I just give on the panel to John to start the discussion and the presentations.
Okay. Thank you, Jason. Thank you, Gabriela. It's great to be here. Great to be moderating this panel discussion. I'm looking forward to the presentation, so I figure we just get right into it. First will be Marcos Acayaba. So with that, I'll just hand it over to Marcos. Is Marcos there?
And my microphone also. Muito bem. Eu vou apresentar. Just excuse me. Muito bem. Eu preparei uma rápida apresentação com esse tema, construções de madeira para lugares desafiadores, para lugares, terrenos desafiadores. Aqui, no primeiro mosaico, mostrando a sucessão de 3 obras, aqui num terreno muito inclinado, 100% de declividade, 45 graus. Aqui já um terreno também muito inclinado, mas com uma questão no meio da Mata Atlântica. Ah, meu Deus! No meio da Mata Atlântica. Mata Atlântica é a nossa floresta tropical costeira no Brasil. E aqui uma outra obra também nesse contexto de terreno muito inclinado e também no meio de uma floresta natural. Essa primeira obra é a casa do engenheiro Hélio Olga, da ITA, construtora, que fez o Pavillion, que está na Praça Mauá. É um terreno muito difícil, vocês podem ver, um terreno com declividade de 45 graus, um verdadeiro precipício. E, para esse terreno, eu tinha aqui uma questão de orientação muito importante. Seria muito mais simples colocar a casa paralela à rua, que está aqui, esse croquis, estaria mais perto do terreno. Entretanto, a orientação ia ser péssima, ia ter muito sol nessa fachada principal durante o verão e muito pouco sol no inverno. Como consequência, houve a decisão de implantar a casa perpendicular à rua, mas ficava esta questão, essa altura toda, como resolver essa altura toda. E aí eu considerei uma estrutura em treliças, um módulo, adotei o módulo de cúbico de 3,30 m, que é o que vocês estão vendo aqui nessa imagem, módulo cúbico, por conta da altura piso a piso e, numa casa, a maior repetição são sempre os dormitórios, que são esses aqui, são dormitórios que se repetem, 3,30 por 3,30 dá 10 metros quadrados, é uma boa área, e um pé direito final, descontando a estrutura e tudo mais, de 2,5 metros. Tem uma série de hipóteses de arranjos de treliças, essas treliças cúbicas, até chegar nessa solução final, nessa equação, que considerou o programa de necessidades, 100 metros quadrados aqui para a área superior, com sala de estar, cozinha, área de serviço, terraço, 3 dormitórios para a família, um dormitório de hóspedes, e mais um espaço que veio a ser ocupado aqui com múltiplos usos. Fundamentalmente, aqui a estrutura é simétrica, equilibrada, considera o programa de necessidades e, fundamentalmente, tem também uma possibilidade de construção sucessiva, de superposição de cubos, de peças lançadas em balanço, atirantadas, cubos em balanço, então, sucessivamente, a montagem sem escoramento, sem necessidade de escoramento, nem de equipamento pesado. As peças são pequenas, de 3,30 metros de comprimento, foram montadas por 3 operários, sem equipamento pesado auxiliar, nem nada, na mão. Aqui aparecem, então, os 2 primeiros cubos já montados sobre as colunas de fundação, mais 2 e mais 2, as primeiras peças sendo lançadas em balanço, os cubos fechados, soltos no ar, em balanço, né? E o último andar da mesma forma. Essa construção, essa montagem demorou 40 dias, né, por 3 homens, como já disse, montando isso manualmente. Aqui está a casa pronta, a casa já pronta, vista de baixo, além dos tirantes, né, nessas treliças de fachada, né, há tirantes transversais para resistência ao vento, né, e a cada nó, né, há um elemento de aço de junção entre viga e coluna e ancoragem do tirante. São esses tarugos de aço que aparece aqui junto ao aparelho de apoio, junto à coluna de concreto, né? Essa sucessão de elementos aqui sonométricos da montagem e a sonométrica das peças explodidas mostra que a madeira vai diminuindo, né, a quantidade de peças na medida que sobe e na medida que vai avançando para a ponta dos balanços. Essa imagem mostra os tarugos, que eu estava dizendo, a ancoragem do tirante. E aqui tem uma treliça central, que não tem tirantes, evidentemente, são de espaços internos. A coluna que corre aqui no centro, ela é sustentada por 2 tirantes que transmitem, então, os esforços, a carga de vertical para a treliça de fachada. É o que está se vendo aqui. Isso aqui são os painéis impulsorizados, 2,5 metros de altura. Há um desvão aqui ventilado de forro, com uma entrada de ar pelos pisos, um sistema de ventilação por convecção. Aqui a casa já vista montada, a garagem está aqui do lado, são portas de correr que, se deixadas abertas, a garagem se transforma num terraço de apoio à piscina. Aqui a entrada para a sala, a entrada para o serviço. A sala com uma lareira central e aqui uma vista em direção à rua e atrás desses painéis tem a escada. Aqui aparece réguas de piso pivotadas para a entrada do ar que corre no desvão entre piso e forro, e entra uma ventilação aqui e a saída do ar quente aqui por cima. A casa é muito alta, muito exposta a ventos, há dias quentes, em que essa ventilação por convecção é estratégica. Essa aqui já é uma outra obra, um outro contexto, né? O pé de um morro, de uma montanha, de uma serra, junto ao mar. O que está representado aqui é rigorosamente a topografia existente, com as árvores existentes, é Mata Atlântica, bastante densa, e um terreno muito frágil. Aparece aqui, né, eu representei aqui nesse desenho, o solo frágil sobre rocha decomposta já. O que faz a coesão desse terreno são as raízes das árvores. Então, mexer nesse terreno é muito delicado e foi estratégico, então, trabalhar com estrutura de madeira, né, com poucos pontos de apoio no terreno, e com a preservação das árvores e, igualmente, da cobertura vegetal. Eu ensaiei primeiro, nesse projeto aqui, eu ensaiei uma estrutura ortogonal, né? É uma casa de 200 metros quadrados também, e o resultado foi a necessidade de corte de muitas árvores, né, importantes. Então, adotei a geometria triangular, foi a primeira obra que eu construí com essa geometria triangular, né? E na verdade, com essa malha triangular, a gente tem mais combinações, muito mais combinações do que com as 2 direções da ortogonal. Com isso, o perímetro, né, das plantas são perímetros mais variados que se ajustaram muito bem, com muita facilidade, às árvores existentes no terreno. Não precisamos cortar nenhuma árvore importante. Aqui está a casa já construída, no meio da vegetação, existente, dá para se ver que é uma vegetação bastante densa. A casa é toda solta do terreno, evidentemente, por conta de enxurradas, chuvas de verão, né? Tem verdadeiras enxurradas aqui que passam por baixo. A casa é necessariamente solta do terreno. Aqui, imagens da obra, da montagem, né? Dá para se ver que as árvores, os pequenos arbustos foram sendo cortados na medida que se montava a estrutura e duas grandes árvores ficaram num pátio central, né? Grandes árvores existentes. E aparece aqui uma delas, uma escada de acesso que vem da rua e um aparelho de apoio aqui com a coluna, que é o prolongamento da fundação em tubulão, né? E o aparelho de apoio com uma peça de aço e as mãos francesas que acabam sustentando de cada coluna um hexágono, né? E um hexágono central deste pátio, né, com as duas árvores pré-existentes. Muito importante esse elemento aqui, que é um prisma hexagonal, todo atirantado, rígido, ele funciona como uma grande coluna central que garante a estabilidade horizontal dessa estrutura, uma estrutura frágil, relativamente frágil. Aqui é o pátio central, com as árvores já que estavam aí, subindo. Em torno do pátio central, de um lado a cozinha, sala do outro lado, e aqui à esquerda um terraço de frente com vista para o mar. Acima desse terraço, o dormitório principal do casal, né, com esse elemento na proa, como se fosse na proa de um navio, né, lançado em direção ao mar, saindo do meio das águas. Uma banheira com chuveiro, uma coisa muito especial. Essa experiência com esta casa, né, ficou claro para mim que daria para essa estrutura tinha uma performance muito grande, muito vantajosa, sabe? Malha triangular, e aí fizemos um modelo de estudo para a Bienal de Arquitetura de 93, onde conseguimos uma estrutura com aproximadamente também 200 metros quadrados, com apenas 3 pontos de apoio no terreno. De cada ponto de apoio, de cada elemento de fundação, uma verdadeira árvore de mãos francesas, né, seguram um hexágono. 1, 2, 3 hexágonos. Por sua vez, seguram um hexágono central, tanto nesse piso quanto nesse. Esse modelo de estudo eu apliquei na execução da minha casa mesmo, em Tijucupava, que é próxima à Casa Baeta, aquela casa anterior. Mais no alto do morro, então a vegetação é menos densa, fica na cota 90, e apenas a 150 metros de distância do mar. A diferença do protótipo, do modelo de estudo, é o aparecimento desses balcões em balanço e de uma grande cobertura com um terraço-jardim, que é de onde se supunha que se teria vista para o mar, é o que está aqui. Isso aqui são 2,5 metros, né, protegendo as fachadas de madeira das chuvas, né, muito fortes, e às vezes, como está na frente do mar, né, no alto do morro, tem chuva de vento, né, chuva de vento que bate nas fachadas. E uma ponte faz a conexão até a rua. Os 3 elementos de apoio estão aqui, instalações todas aparentes, essa é uma área de serviço que é pendurada, e aqui esses tubos são tubos de águas de chuva, né, que são lançadas sobre o terreno para garantir a umidade original do terreno, sem provocar erosão e nem enchentes. A vista de baixo, mostrando a estrutura e a sucessão de tramas triangulares de apoio, fotos da montagem, né, também de uma coisa montada sem escoramentos, de dentro para fora, abrindo na medida que sobe, né, e aqui tem um uso de pré-moldado de concreto sobre a estrutura de madeira, pré-moldado leve de concreto, 4 centímetros. A casa aqui está pronta, já no dia que o sol estava nascendo. Uma vista debaixo da ponte, olhando para a casa, né? Esses painéis são todos industrializados, tudo aí. A montagem foi muito rápida, essa obra durou 4 meses ao todo. A montagem da estrutura também foi 40 dias. A vista da sala, a ponte que chega da rua, aqui atrás disso está a cozinha. Essa escada sobe para o terraço de cobertura e desce para os dormitórios. Tem uma alternância de balcões e bay windows. Balcões e bay windows com a mesma geometria semi-hexágonos. Então, essa alternância de balcões e bay windows acaba fazendo vamos dizer, uma interlocução muito interessante com a vegetação em volta, com a copa das árvores que está em volta. A cozinha é um bay window também, dormitório também, grandes janelas de 2,5 metros, né, que é um módulo, e o terraço de cobertura com vista para uma península que fica aqui perto. Né? Uma outra vista com o sol nascendo no oceano. Bom, essa era a apresentação que eu tinha. Quanto tempo eu tenho? Ainda? Quanto tempo foi a minha apresentação? Já eu não cronometrei. Ah? Bom, isso aqui é rápido. É o projeto de concurso da Estação Antártica, concurso que eu fiz com o escritório Base 3, Marina Grinover, Caterina Otondo e Jorge Pessoa. É de 2013, esse concurso. É a Estação Antártica do Brasil, um projeto que adotamos como estrutura de madeira, produzida no Brasil, no sul do Brasil, madeira de reflorestamento e transportada com pouco peso, né, em montagem rápida na Antártica. Essa era a tese. O edifício principal, aqui laboratório, edifício de laboratórios, tem esse edifício para mergulhadores, para...
A gente não está vendo a apresentação.
Não está vendo?
Não, você consegue compartilhar o PDF novamente? A gente não dá para ver.
Desculpa, hein?
Imagina.
Puxa vida. Espera aí. O que está acontecendo, meu Deus? Mas eu estou mostrando... Eu estou partilhando... aqui, desculpe. É esse aqui, chefe. Agora sim. Desatenção, mais uma vez.
Está funcionando perfeito.
Já entrou? Entrou?
Entrou, tudo certo.
Tá, deixa eu encher a tela, pronto. Então, a Estação Antártica é esse projeto. Também tem uma origem de uma estrutura triangular para esse edifício principal. E aqui é ortogonal para os laboratórios por conta de uma flexibilidade de mudanças de layout. E aqui um edifício, no meio, um edifício de serviço, garagens e oficinas, e que desde o início iria ser, vamos dizer, o canteiro de obras. Se montaria primeiro esse edifício, depois para a montagem dos outros. Planta térrea, cortes, são cortes esse corte aqui é um corte que se vê assimétrico, porque é um triângulo de superelipse, uma superelipse de triângulo. Aqui é o edifício de serviço e os laboratórios. A tese aqui é um terreno muito desafiador por conta de baixas temperaturas, às vezes são 8 meses por ano que não se pode sair, né? Então, importantes espaços de convivência internos, né? Isolamento e inércia térmica também, e fundamentalmente, uma questão muito importante nesse caso é a resistência, quer dizer, não oferecer resistência ao vento. São ventos de mais de 200 km por hora. Então, os edifícios todos, né, não têm arestas, são edifícios sem arestas. Fizemos ensaios em túneis de vento, né, simulados em computador, e o resultado foi excelente. Esse é o edifício principal, com cabines, né, um espaço de convivência no centro, auditório, refeitório, e aqui são os laboratórios. Aqui são as várias sistemas de aquecimento, energia, água potável. Aqui, emissão zero, né? Absolutamente emissões zero. E também, aqui, importante esse corte aqui, é interessante ampliar, se puder ampliar. É um corte mostrando exatamente o anel de cabines em volta do espaço central de convivência. Essa geometria da cobertura tinha a intenção de degelo, quer dizer, a neve derretendo, captada por essas grandes calhas, e aqui havia um shaft de instalações, e essa água era armazenada, né, em grandes tanques. Aqui foi a forma que encontramos, tanques que serviam para reabastecimento de água e para dar inércia térmica a esse edifício que sendo todo de madeira, tinha pouca inércia. Então, inércia térmica aí é para conseguir estabilizar a temperatura, né, ajudar na estabilidade da temperatura. Aqui mesmo também esse tipo de solução, né, uma espécie de estufa com irradiação de calor para dentro, né. Cabines, laboratório, esse é um corte do laboratório, isso tudo é madeira com isolante térmico, né. E aqui um laboratório distante, né? Tinha isso aqui também. Isso aqui mostra bem o sistema estrutural, isso foi muito importante. Isso tem como referência, né, a construção de barcos, de casco de navio, né, de veleiro, cavernas. São cavernas, a cada 2 cabines tem uma parede de madeira estrutural apoiada sobre 2 mãos francesas, né? Então, esses conjuntos de mão francesa, por sua vez, têm fundações. Isso aqui viria do Brasil, né, pré-moldado de concreto, né, um bloco de fundação com atirantamento no terreno de rocha, porque o problema maior aqui é resistência a vento, não é carga. Então, essa é a montagem da estrutura, tem esse anel todo estruturado como se fosse um casco de navio. Aqui o laboratório, uma vista já da salão de estar e do espaço central de convivência, com esses tanques de água, que são os tanques para garantir inércia térmica. Aqui uma área toda central de padaria, cozinha e tal, refeitório, biblioteca no mezanino. Isso aqui tudo é vidro, né, uma grande claraboia, uma vista noturna do cais, né, praça de trabalho, e uma última vista noturna também mostrando os edifícios em relação ao mar. A equipe, né, dos arquitetos, estrutura, projetada pela Blumer Lehmann, né, empresa suíça, Martin Antemann, engenheiro, e Lili Schindler. E toda essa equipe aqui trabalhando com a coisa das instalações, de energia, das emissões, etc., etc. Pronto, era isso. Muito obrigado.
All right, thank you. Thank you, Marcos. Thank you very much for presentation on projects in challenging locations. I guess there's nothing more challenging than Antarctica. And I'll admit those houses, even though they're decades old, look fresh now. But with that, I'll bring in Josep so he can present, and then we'll talk later. So Josep, you're next.
Hello, thank you, John. First of all, it's a pleasure to share this webinar with Marcos Acayaba. For me, it's a master, so it's a pleasure to share that and to listen and to talk about his houses and his work. And thanks to Jason and Gabriela for the invitation too, and congrats to Jason and even to Diego, Sebastian, etc. for the pavilion. That I think it's a very nice pavilion, this Future Now pavilion. So congrats for this work. And I will begin to share some of the projects and the things that we'll talk about. So let me begin with this image that I used to begin with that, because I think that it resumes what I want to talk about, that in fact Marcos has been talking about. No? So I think that I always like the beauty of this bird nest, because the beauty related to the objectivity, not to the subjectivity. So it's not related to the taste. It's related to the objective things like monomateriality, geometry, and efficiency. So this element, this home, works with only one material, and then understand the qualities of this material in order to use it in a respect way, and in order to use it as it works. For example, bending, in that case, not like concrete or not like glass or not like steel, but at the same time, it bends, but it's rigid enough to avoid to break it. So working in materiality is to understand the material as being able to be skeleton, to be bones, to be muscles, to be skin, so to be all the parts of a space. It works by geometry, so only bending and assembling. You don't need screws, you don't need glue, you don't need other materials. Only with the same materials, by geometry, you assembled it, and then you build that space. And at the same time, it's efficient because it works by circular economy. So with these branches are coming from the tree close to the place that the bird wants to build it. And at the same time, when the bird is being bigger, this bird nest will fall down, and there will be organic compost, and then we will have another tree, etc., etc., etc. So monomateriality, efficiency, and geometry are three words that are related to the wisdom of that space. And talking about flexible systems, I want to talk about this idea about how the systems should be flexible in order to be rigorous instead of rigid. But the flexibility should be systemic in order to avoid to be aleatoric and to be rigorous. In that ways, let me talk first about some things like two concepts related to the materials. The first will be the stereotomic materials, and the second one is tectonics materials, because I think that the work that I try to make is always like in a fuse limit in between both concepts. No, so stereotomic is something more related to the idea of cave. It's related to the idea of massiveness, related to the idea of compression, etc. Like this university in Buenos Aires that is working in this kind of tripartita facade, where you have every part is adding one floor, no, 1, 2, 3, and every floor is subdivided in 3 or 2 successively. So it has a continuity. It's a very classic, but at the same time, it works with this idea about concrete that is more a stereotomic material, is talking about heaviness, but at the same time it's talking about the idea of wrapping, no? With this idea that I was talking about cave. Or the same happens in that house in Paraguay, in Asunción, Paraguay, now where two frames are defining a porch. Only a porch that at the same time that is defining a closed horizon, that is a sure place, etc., is defining over the frames kind of a green platform that connects with the far horizon. So again, this idea of having big spans that allow you to understand a place inside a cave. But at the same time, with this, again, these small differences, no, where the slab is supported or is above the two frames with these little elements, no, that allow the hot air to go out and to work in some kind of energy efficiency. No? or for example, these houses that we're now beginning to build in Balearic Islands that are made by the local stone, Mares. And this local stone is producing this kind of a very like vernacular construction. When you are inside, you feel this, no? But you feel that you are inside scoring. No? So you're feeling that you are inside a cave of stones. No? So if atomic materials are talking about the massiveness and wrapping the space, tectonics are just the opposite. No, they're talking about lightness. Sometimes even they're talking about traction, but at the same time they talk about pieces that are smaller than yourself. No, so instead of wrapping, they have a smaller scale than you, but that they're able to build bigger scales at the same time. No? For example, like this project in Mendoza, in the west part of Argentina, that was like a steel matrix inside an industrial building. Or for example, this project that was the project was finished like 1 year ago, more or less. I hope that someday they will build it. Is the refurbishing of the old Casino da Urca in the Playa da Urca to be a university school of design. And these are all the scaffoldings that were, the idea was to use all the scaffoldings that are used to consolidate the ruin in order to inhabit the ruin, are the pieces that are able to inhabit that place, to promote, also to suggest to the students to change every semester, every academic year, that place, to inhabit these ruins in different ways. No? So the question of how you use the tectonic elements that you need for a construction, in order that these elements, in order to go out when you finish the construction, are the ones that you use to inhabit the construction that has finished. Or for example, this competition that is for the International Antarctic Center, that works more or less in the same way. You have this basement, concrete basement, but then you have this steel construction, again, working with this tectonic condition, like adding in a fractal way and this kind of inverted pyramids in a way to understand that sometimes is diffuse even the limits between what is vertical and horizontal. So here the horizontality is made by increasing the density of the verticality, or just the opposite. No, the verticality is made of reducing and increasing the scale, so reducing the density and increasing the scale of the horizontality in order to generate verticality, as you can see in that place. This is something that we will see in different projects. No? So constantly this, how to dance or to diffuse the limit between tectonics and atomic, but at the same time, it's a verticality related to horizontality. So instead of working with columns and slabs, sometimes it's diffuse. No? Or even this idea, this dance between stratomic or weight and light, is this ephemeral installation that was made for 3 days, where we were using 2 rolls of fabric and 200 tons of steel profiles in order to produce this displays that it was 3,000 square meters. And after using this material for 3 days, we moved back these materials to their companies in order that we produce zero waste material and zero budget in terms of material itself. No? But at the same time, working with this idea of traction, lightness, or compression, heaviness, etc. No? So related to flexible boot systems, I will show you. I will begin with some installations. Some of them ephemeral, some of them permanent installations, and then later we'll see. We have time to check some other bigger projects. No? For example, that one. This is that was a project done in 2014 in front of the Barcelona Cathedral. It was ephemeral for 3 months, and we were working with only one piece. So the idea was how to synthesize the complexity that we needed to have here. No? The complexity is related to different things. No? One is how you build something that nobody is moving, so it has enough weight, that nobody is able to move it. But at the same time, that is distributing the loads in order you don't need foundations, in order to avoid to destroy the place, because it's ephemeral, and it was for it was built here for 3 months only. And the other thing is how you build with materials that it works in some kind of a circular economy again. No? So this was built with wood in order that these elements in groups of 1,000 pieces, they were moved after this installation to different kindergartens of the city, and the kids were using it as a playground. And after kids destroying these playgrounds, they were used as a compost in the same schools. So 8,000 pieces were able to build this kind of former or reproducing some kind of former Roman aqueduct in the limit of the former Roman city of Barcelona. In one side, and the other side was such a big Catalan fault, but at the same time, the orthogonality is able to talk about the enlargement of Barcelona, so the contemporary city. So 3 moments of the 2,000 years Barcelona history represented in this kind of abstraction. At the same time, this piece, as I said, the idea of all these projects are trying to be always very synthetic. So how you can have the more synthetic answer to such an amount of questions. No? So how to reduce the complexity in something that sometimes seems easy. No? So this piece only like twisting 90 degrees, the same piece is producing from one line to a plane, but the symmetric conditions of this element produce that the same piece is rotating and it's producing a 3-dimensional installation that allow at the same time that the limit of this element is not plane, so nobody is able to jump or to climb, sorry, to go up, but at the same time it's touching the ground in a very like elegant way. No? So it's touching in some points, as I said, distributing the loads, and it seems sometimes that it's like almost floating. Only repeating 8,000 times the same piece. No? For this project, that this is a permanent installation, was a cultural pavilion in Buenos Aires. I built this kind of this kind of stairs that are assembled. So four equal stairs that are assembling, producing some kind of spiral effect that move the people from the level 0 to the level 3 meters. In order to domain the 2 horizons, no? The horizon of La Pampa and the horizon of the river La Plata River. So there are 4 stairs that are producing this kind of labyrinth. This is a labyrinth not because cutting or opening pathways, it's a labyrinth because the disorientation. No? This is that you see these 4 stairs that are assembled. That's the question. So you see the continuity and discontinuity of these stairs, producing at the same time that you have a point of contact of the 4 stairs that is in the level of 1 meter, just in the center, producing this kind of agora. In order that when somebody is reading something or is playing music, whatever, the stairs are becoming some kind of agora, floating in this landscape, floating in this park. So in fact, here we're constantly seeing the same kind of stairs, but because rotating that, you perceive that everything is more disoriented. All the pieces are always equal, but different length. So it's 5 per 5 centimeters, so 2 inches per 2 inches pieces with different lengths. And even when they are together, so they are working with this kind of rotating system as the stair is doing. So in this kind of multi-scalar way of working. So the detail is the space, as the space is the detail. And obviously the density is changing. So when you're going down, you have more pieces together. So you decrease the density, but you increase the aggregation in order to become the space becoming more permeable in the ground level. But when you are going up, you are increasing the density and decreasing the aggregation in order that you have that this density is avoiding that you fall down at the same time, because you need less aggregation because you have less loads. this wheel that we built in 2015 in the Cian, in front of the Cian in the desert. That was even Sebastian and Diego were collaborating in this project. It was a threshold that I had to design a threshold in front of these 16 houses for Ocho Cubo, which is a promotion that one developer, an engineer that is developing this promotion, was asking me to design a threshold, a door to that place, but even without telling me where this door should be located. So then I was taking advantage of some kind of railway tracks here, in order to use it, in order to put some element there that talks about movement, talks about about an element that is able to be everywhere and nowhere at the same time. So after asking to the client, where do you want the door? And he was answering that where you want, the answer, the final answer was whatever everybody wants, because the idea was that constantly this door would be in movement. And this study about movement is again related to this wheel, 6 meters of diameter wheel, is made by composed by the small pieces, as we can see here in this kind of cage by designed by Graham Bell, with the idea that instead of having some kind of continuity related to the wind, you have discontinuity related to the wind. So it's something that is it's like a lattice, but at the same time, it's something that collects the wind to move. Or even checking these drawings by Leonardo da Vinci, you can notice how constantly he was thinking that a wheel is composed of wheels. So it's impossible to make one wheel, because normally there's a wheel that is the one that is moving. There's another wheel that is collecting the energy. There are other wheels that are collecting or they're changing the direction, or they're increasing the speed, etc. So we're working with these 8 wheels that are 4 per each side, with 800 equal pieces, but with different angles. So there are 8 different angles in order to be adapted, the wheel to be adapted to the geometry of the radius of the circumferences, just in the center, and to be related to the geometry of the circumferences at the limit. So here we can see how these connections connecting these 800 wooden pieces. It's the moment that you cross that place. And the idea was to use the rail tracks in order to be related to the landscape scale, because in this scale, this kind of projects, it's very important to understand how you relate to the landscape and how you relate to the people. So in the stairs, I was provoking the people to move up, that when you see the landscape from another point of level, you perceive that you are domaining or you are controlling the landscape. In that case, putting the wheel or putting the threshold above the tracks, we were using the track in order to understand that in order to define the limits of the projects are not the limits of the construction. This is a house next to this project, to the wheel, and the same client asked me to design a house for nobody, nowhere, and that was even more difficult. So the idea was, okay, how I do a house like this, So then the answer was how to make a house for everyone, everywhere, And then as it's a house without client, and a house without place is a square, so it's a very Palladian plan. It's a square, because it doesn't have orientation. So and then it's important to be isotropic. At the same time, this square is divided in 9 squares, and this 9 squares has 8 squares that are on the perimeter and 1 square that is in the middle. That's because this house is called house 8+1, because there's one that is the only one that is not able to change its use. The rest, the other 8 squares, you can change the place, and you can distribute that as you want. So in that case, it's more like a Japanese house where you have in the undefined places places with enough scale or enough dimension in order that you perceive that they are undefined in terms of use. So instead of spaces that are imposing a use, are spaces that suggest different uses. In order to make that, this is thought as an infrastructure. So when you see these rectangular pieces that are 3+3/1, are pieces that are containing points of water, so humidity, wet areas, or there are places for storage. So what I was doing is separating all the pieces of the bathroom. So instead of understanding the bathroom as a room with pieces, you divide the pieces and you can concentrate the shower, the toilet, or the sink in different places. And then you have this kind of wooden columns or wooden void columns that are able to receive the storage places and the wet areas. So first of all, you have 4 concrete beams that are avoiding that the wood is touching the ground. At the same time, this beam is dealing between the topography and the horizontal element of the house. And then you have this wooden grid on the floor and the roof, and this kind of intermediate grid that is the space that you inhabit. That you can inhabit in different places. You can inhabit like this, no? For example, with bedrooms in this vertical direction, or living, kitchen, dining room in this horizontal direction. But it's something that could change because you feel that you had a mistake, and it's better to move that in different way. It's changing because the seasons. It's changing because you have more kids, or your kids are not coming to this holiday house, etc. So that produce this kind of flexibility, no? So it's a very rigorous system, but at the same time that allow you to have a lot of flexibility. The only place that doesn't have vertical facade is the one on the center. As I said, the only one that is not changing is the kitchen. So in fact, it's a very, very vernacular or very primitive house. No? So the first home is the people surrounding a fire, a fireplace, or a fire for cooking. So this is a house surrounding a kitchen where you have an Etfe roof in order to provide natural light in that place. It's working constantly with this idea of diagonalizing the space in order to produce this perception that the space is bigger than it is. So opening the corners, you're always opening the diagonals, which is the maximum distance in a space. But at the same time, opening the corners, you're avoiding cul-de-sacs, and then you have constantly, again, this idea about desorientation, this kind of labyrinth where you're constantly like these kids going around these infrastructure boxes. No? So sometimes this holidays house is a house that sometimes it seems that is under construction with abandoned. And the last one in the same place, the same client was asking me to think about how to do for rooms for a hotel, but in fact it's like only 4 rooms in that place in order that the future clients could spend one night in that place. When we went to visit this, again these 16 houses that weren't built when I designed and we built the wheel. When we visit again that place, 2 houses were under construction. The house by Ruyen Ishizawa, there was an amazing house. There is like a wave of concrete. And another one that is the house by Alejandro Aravena, that again made in concrete. But I was asking to the client about that, what's happening with all this wood. And he was telling me that this wood is, as we see in the picture at the end, or just there, we see that there's plenty of wood that they burn or whatever. And I was asking what happened with the workers, because this is a place that it's not easy to have people working here, etc. Because I was asking about how to make this kind of scaffoldings, because I was impressed with the scaffolding, only using two kind of pieces. One piece of this one that we see the heads in green color, that are 3 inches per 3 inches. And the other ones that are more like these diagonals, that are flat elements, they are not squares, that are the ones that they use as a formwork. And what they said is that, okay, don't throw out this material and don't say goodbye to these workers, because the idea was to work in the same way, to use this kind of scaffolding knowledge to build the hotel, a hotel that is reusing the material used in the construction of the construction of the Aravena's house, to build this hotel, a hotel that again is like almost floating, no? Understanding that that this is a place, or this is a construction that is here for a certain time, so the landscape is passing through underneath, and you are only reusing these elements, producing a lot of density, because these pieces are, as I said, only 3 inches per 3 inches. So it needs a lot of density in order to be self-supported. And the diagonals that I was using the formwork from inside and from outside. Again, this idea about how the book talks about time, I think is really important for me. Thank you.
Great, thank you. That last project was actually really great to see, because we saw the image for the event, but to hear the story behind it. I'm hoping to see photographs in near future. I'll just remind the people watching on Zoom that they can ask some questions in the chat, and then following this discussion amongst the three of us, I'll read some of those questions. So Josep and Marcos, just wanted to start with the similarities and differences between your work, kind of focusing on the work that is like the theme of this talk, or the theme of this panel, doing with wood construction. Because you know, 2 architects, 2 living on 2 continents, 2 generations, and you know, there's obviously going to be similarities, differences. Something I observed in the presentations was some of the projects seemed to allow, by using wood, you were able to make decisions, say, on site, or it gave you the flexibility, Marcos, with the project where you tried to preserve trees, for instance. And then Josep, the one in Barcelona, with these small members that you could, I imagine the form of that pavilion could have taken many different iterations as you were doing it. So, but I want to hear what you guys see as similarities, differences in the others' work. So I just want to kind of get some feedback from you on how do you react to the other architects' work as you saw the presentation. Josep, if you want to start, please. Or Marcos, whoever's ready.
Thank you. No, I think that as I said at the beginning, also I sometimes, several times I begin some lectures with this bird nest image, but and I talk always about the knowledge of this, no, to say monomateriality, efficiency, and geometry. And as I said at the beginning, no, I saw exactly all these things in the work by Marcos, no. So is this kind of knowledge, no, that it works by geometry. So we've seen in the first house with the cubes, the second house with hexagons, etc. So something that is very attractive is that you see the house is always complete and incomplete, and this is amazing. So the second house, for example, is very nice that you in this hexagon system, no, that you see the house and you, okay, it's finished. But if somebody is telling you, can I have one more room? There's no problem. the house will be exactly the same. Can you take out one room and to be a terrace and will be exactly the same? This is what is amazing, is the idea of working with systems instead of with forms. When you work with systems, you work with geometry, and the forms is a certain result of this geometry in a certain moment. When you work with forms, it's very difficult to make additions or subtractions because it changes totally, no? So I think that what I see in the work of Marcos, that obviously I knew it, no, is a very deep knowledge about the wooden construction in terms of pieces, no? So, but because this is another thing that is important, that he has worked obviously with other materials like concrete, etc. No? But when you work with concrete, you work with the idea of this idea about wrapping, no? But when you work with wood, you know that you work with pieces that are smaller than you, that are able to shelter you. And then this is very important, no? Even the joints, no? So when you work with concrete, you need to understand that there's a dance between the formwork and the concrete. So there's something that exists first and later disappear, no? And with this kind of wooden construction, you work with two things: the element and the joint. And the joint is very important, no? So I think that, well, it was marvelous to listen, Marcos, in that way, no? So in fact, for me, was that like the bird making the nest.
And Marcos, how would you respond to the work of Josep? You're muted, by the way, Marcos. So no, Marcos, we can't hear you, so you just need to unmute.
Sim, é verdade. Já. Muito simpático seu comentário, José. Foi muito bom ter ouvido isso. A ideia do ninho é muito interessante, né? Como você tematizou isso. Agora, o seu trabalho é muito bonito, muito interessante. Essa casa, essa última casa que você mostrou, tem essa referência evidente na arquitetura japonesa, né? Essa continuidade de espaços, né? E flexibilidade de uso dos espaços. E é muito bonito como você organiza com muita clareza, né, esses elementos fixos, que são elementos núcleos, né? São núcleos, né, de equipamento, né? E a partir disso o espaço fica livre, fica contínuo. Muito interessante até a imagem das crianças correndo, né? Essa ideia, gosto muito dessa não existência de dead ends, né? De cul-de-sac, né? Essa coisa do percurso, na medida em que o espaço a gente percebe através do movimento, né? Um movimento contínuo e múltiplo, né? O espaço também passa a ser contínuo e múltiplo, você multiplica o espaço. É muito bonita essa sua composição, né? Muita clareza, uma coisa admirável. Eu fiquei muito contente em ver essa última casa, além dos outros projetos, todos muito interessantes, né? Todos. Tudo muito leve, né? Tudo muito leve, muito flexível, muito inventivo. E a referência no ninho, né? A primeira imagem está dada em todo o percurso seu. Gostei muito mesmo. Muito obrigado.
Muito obrigado.
So before the talk, I was looking at Marcos's website, and I liked how you, Marcos, spelled out the philosophy of your work. And specifically, if I'm understanding it correctly, you start with the characteristics of a place, and that kind of helps to determine the strategy of the construction, which then informs, again, the conception and the design. And also, it sounds like the longevity of the project, kind of what can happen after it's built as well. I was just hoping maybe you could speak a little bit about that, specifically what goes into determining if you do a timber building versus one that's, say, not, that is concrete or steel, for instance.
Teve projeto recente meu que tinha sido terreno difícil, né, acidentado, uma declividade muito grande para o fundo, a partir da rua para o fundo, né, e um terreno de difícil subsolo, né, já tinha sofrido deslizamentos, né. Então, o primeiro projeto que eu fiz era um projeto com estrutura de madeira. O projeto foi todo dimensionado, né, estruturalmente pelo Hélio Olga, né, na ITA Construtora. Entretanto, esse projeto, né, eu não tinha... O projeto foi evoluindo em relação a questões de contenção do terreno, contenção do solo, né, e aí tinha elementos de concreto, de contenção, né, e para ajudar nesses elementos de concreto, de contenção, eu abandonei estruturas de madeira que não tinha rigidez suficiente para contribuir nos esforços de contenção do terreno e acabei fazendo um projeto de aço. Teve uma versão em concreto, mas o terreno é muito acidentado e ia me obrigar a fazer cimbramentos muito altos, escoramentos muito altos, né, para fundir concreto. Então, abandonei o concreto e acabei desenhando uma estrutura de aço, que vamos dizer, um engenho de ajuda ao escoramento do terreno, né? Quer dizer, já houve projetos em que eu acabei resolvendo todo o dimensionamento, né, de espaços e a própria geometria muito determinado pelo subsolo. Houve já projetos e a partir, né, do comprimento que ia ter das estacas para chegar no solo resistente, no subsolo resistente, o comprimento de estaca, para ser pré-moldada em concreto, ela tinha que ter uma determinada dimensão, suportaria uma determinada carga. A partir disso, eu fiz o dimensionamento da estrutura. Quer dizer, às vezes, são questões técnicas, né, como essa, assim, do terreno, né, do solo, né, que determinam a escolha do sistema construtivo, né? Às vezes são outras questões de fornecimento de material, de acessibilidade do terreno. Às vezes é dificuldade da instalação de canteiro de obra. O canteiro de obra também são questões determinantes. E tem outras questões também de clima, de paisagem. Essa questão da Antártica, por exemplo, né, a questão dos ventos, de mais de 200 km/h, nos levou a adotar superfícies todas muito aerodinâmicas. E para fazer isso, a técnica construtiva para fazer isso, hoje é com madeira que se faz, né? É o melhor material. Você moldar superfícies curvas, né? Volumes curvos. Então, tem uma série de questões. Às vezes, são outras questões também, questões de contexto urbano que determinam, né, a técnica, a estratégia de obra. Eu chamo mais genericamente, de uma forma mais ampla, estratégia de obra, né? Como melhor realizar a obra que é necessária realizar. E isso vem a ser, para mim, como se fosse uma bússola, uma referência para a concepção do projeto. É diferente da adoção de um partido, né? Que, a meu ver, é alguma coisa que tem a ver com a Belas Artes, a escola de Beaux-Arts, né? Partido, em geral, tem uma solução a priori, de ordem plástica formal, seja de espaço interno, seja de volume, né? Enquanto que, desse jeito que eu acabei costumando trabalhar, né, é uma coisa mais de dedução da forma, dedução da geometria necessária e dedução até, né, rigorosamente, eu espero, né, do sistema construtivo. Eu acho que é isso que tem me levado
Yes, I think that very like a short comment. No? I think that is, I think in both cases, we work with the structures, thinking that the structure is not the one that supports the space. It's the one that defines the space. That is different, no? Because normally when you, so that support the space is something that is logic, no? But normally sometimes, and again, it's related to the idea of form or system, no? So when you work with form, sometimes there's some structure that is hidden in order to support that form, no? In our cases, we don't work in that way. We work in a way that the structure is the one that defines the space, and then it's different because at the same time that supporting it is defining it and it's inhabiting the space itself, because the one that you perceive as is organizing even the space. No? And in that way, I think that so we choose the material, or at least in my case, no, I choose the material depending on what kind of space I want to define in that place or for these people or for that program, whatever. And the second thing is, which are the resources that we have. So what do we have close to? What is the knowledge of the workers in that place? Which is the climate, as Marcos said, no? So which are the resources in terms of material, workers, climatic conditions, etc. That's the first thing. And the second thing is that which is the kind of space that I want to define with this structure. And then the material is decided in these two conditions, resources and space.
Concordo com você, mas é muito próximo, estamos muito próximos. As questões são mais ou menos as mesmas. Eu acho que talvez haja ênfases um pouco diversas, né? Uma questão de ênfase, mas filosoficamente eu acho que estamos muito próximos.
And I was hoping to get some feedback in terms of wood and sustainability, because certainly it's, wood is going to be increasingly used as it's a, it holds carbon, and there's more and more sustainable management of wood, like ITA in Brazil. So, but there's also at the same time there's a widespread perception of wood as a more fire-prone material, and one that is not as strong in a fire versus concrete and steel. But studies have shown that that's not so simple. It's not necessarily doesn't align with that. So I'm just curious kind of where you see things going, or what sort of advice you have in dealing with, for instance, if you have dealt with regulations in terms of, resistance to mass timber or what have you,
Yes. Well, I can begin, because one of the projects that I finally didn't show is that it's a fire station made in wood, completely in wood. So in fact, I don't know, half year more or less ago, I finished the fire station made completely in wood of Spain. And the firemen were like joking. I was joking. There is no problem because you're close to. But there are two questions that I love of the wood. First of all, is that we always associate the wood to the fireplace, and then we think that it's burning very fast. But in fact, it's less conductive than the steel. So the steel burns or collapse faster than wood. That's amazing. So you don't think so? Normally, you associate, as I said, the wood to the fireplace, and then you don't know that, but it's less conductive than steel. And the other thing that I loved is that when you have steel and you have to protect from fire, whatever, you need another material. So you put some kind of other materials, but even with other materials, you need other materials to protect it. With the wood, it's very interesting because the only thing that you have to make is to increase the dimension. So you don't need another material; it's the same material. So if you need a beam of 20 centimeters, and you know, for example, that that you need to protect this beam from fire, for example, 60 minutes, no, you increase 5 and 5, and then perhaps it's 30 centimeters. So what you are seeing is 30 centimeters beam. That in fact, the one that works, the one that is mechanical working, no, in terms of structure, is 20 centimeters, but the rest is protecting the structural part. And then I think that that's amazing because you're not using other materials, so there's no skin. It's the material itself that protects itself. No? And in fact, I was proposing to so I built this fire station, etc. And they were worried a little bit about the maintenance of the wood. And I was proposing this Japanese technique, no? That what you make is to burn the first 2 millimeters, and then this burned wood is the one that protects the rest of the wood. No? That wasn't accepted. So they were accepting wooden construction for a fire station, but not a born wooden construction for a fire station, no? Because they thought that it was too much. But I think that it's interesting how you play with the material itself in terms of regulation. So you don't need to add things. It's only conditions, self conditions to make that. No?
And actually, there's a question from the audience that's kind of related to that. This is from Francesco. This is to both of you, so to Josep and Marcos. And he writes, there is a similarity in your design methods and necessary reference to Japanese architecture. And could you explain your connection with that tradition and the genesis of your approach to design? You want to start, Marcos?
Sim. Eu tinha, desde criança, no Parque do Ibirapuera, em São Paulo, durante o quarto centenário, houve montou-se e continua até hoje, um pavilhão japonês. É um pavilhão japonês que eu conheci quando criança, uma arquitetura japonesa e com uma exposição do Japão aqui em São Paulo, em 1954. Foi a primeira referência. Depois, na época já de faculdade, eu procurei muitas vezes livros de arquitetura japonesa tradicional, especialmente. Andei estudando bastante isso. Né? Acabei comprando uns livros já na época de faculdade, fim de faculdade, livros de arquitetura tradicional japonesa, e um livro precioso do Katsura, né? Palácio do Katsura em Kyoto. E andei estudando muito, eram livros muito bons, livros com levantamentos e detalhamento. Né? Quer dizer, eu tinha uma admiração grande pela arquitetura japonesa, até que teve uma leitura de um livro em que fiquei sabendo de que para as religiões derivadas do taoísmo, né, do budismo inclusive, né, espaço e tempo, né, são a mesma coisa. Inclusive, parece que é uma palavra só que designa espaço e tempo, diferente de nós ocidentais que fazemos uma distinção entre espaço e tempo. E por conta disso, a arquitetura japonesa tradicional, salvo os templos, ela jamais é simétrica. jamais ela tem, vamos dizer, uma forma acabada, um retângulo, um quadrado. Sempre tem uma certa simetria, porque se acredita que, se o espaço é acabado, o tempo também está acabado. Não tem como se manifestar e transcorrer, né, o tempo. Então, sempre, quer dizer, essa composição da arquitetura japonesa tradicional, né, baseada no tatame, os espaços baseados no tatame, tem a ver com isso, e o que acontece na vida real é que, quando numa casa vai vir um filho, né, tem que se fazer um novo espaço, o dono da casa ele acrescenta no croquis, acrescenta os módulos de tatame, quer dizer, a composição de tatames para um novo ambiente, né, que vai ser acrescido para a chegada desse novo filho. Vai até ao armazém da esquina, né, e compra peças prontas que estão lá estocadas, todas estocadas. São peças leves, né, que ele leva manualmente, carrega para a sua casa e acrescenta esse novo ambiente, né, àquele organismo já existente que é a casa dele. Quer dizer, é uma coisa de transformação. A partir do tempo, o espaço se transforma, né? Pode se transformar porque não é fechado. Quer dizer, essa característica veio encantar, né, os ocidentais, quando descobriram isso, primeiro Bruno Taut, depois Frank Lloyd Wright, né, que até passou a fazer a arquitetura orgânica do Frank Lloyd Wright. Quer dizer, isso, para mim, foi uma descoberta. Né? Foi uma descoberta. Estudando, cheguei a descobrir isso da arquitetura japonesa. É claro que quando eu comecei a trabalhar com madeira, né, a primeira obra que eu fiz com estruturas de madeira produzida pelo Hélio Olga, na Ita Construtora, eu me disse para mim mesmo, assim, puxa vida, se aprender a falar essa nova língua, é uma nova língua, uma nova linguagem. Né? Nada como aprender com quem fala essa língua há tanto tempo, né? O japonês, que tem estruturas de madeira, vamos dizer, pré-fabricadas, pré-executadas, estocadas em peças padronizadas, né? Desde o século VII, século VIII, coisa assim. Tá? E os japoneses fazem essa arquitetura admirável. E essa primeira casa que eu fiz foi uma casa meio japonesa. Por sorte, eu tinha um projetista que trabalhava comigo, um japonês nascido no Japão, desenhava maravilhosamente bem, e nós, assim, com os livros que eu tinha de arquitetura japonesa tradicional, tudo com detalhamentos muito bem feitos, né? A partir dessas referências, fomos construindo um discurso, né, com peças padronizadas do Hélio Olga. O Hélio me disse simplesmente o seguinte: olha, o módulo ideal é 5 metros por 3,5, barrotes a cada 50 centímetros, é uma modulação de 50 centímetros. Né? A partir disso, nós fizemos na primeira casa, isso foi em 1985, 86, né? E com um jeitão bem japonês. Né? Foi uma realização de um desejo antigo que eu tinha de falar, um dia eu vou fazer uma casa japonesa tradicional. Fizemos. E está inteira até hoje, né, essa casa. Aí as coisas foram evoluindo. Logo depois eu fiz a casa do Hélio, que muita gente me perguntou, mas isso tem muita influência japonesa. Eu falei, bom, naturalmente, né, o sistema construtivo tem a arquitetura japonesa como referência, né, fundamental. É isso.
No, I think that Japanese house is amazing. So it's a house that, linking with the word that Marcos was using, not tatami. No, it's very interesting how in the Occidental world we used to put names, even short names, no, to the spaces. No, we say this is the dining room, this is the bedroom, this is the living room. No, so it's like you can only eat here, you can only sleep here, you can only live here. No, and that's a pity, because and then it's like I think that the houses 100 years ago were better than now, the collective houses, because the collective housing has moved in order to be more specific related to these names, no, to the living, dining, bedroom, or kitchen rooms, no. Instead of the Japanese traditional house, no, that is a house that it's only defining the wet spaces, no, the wet areas, like the kitchen or the bathroom. The rest are defined by the number of tatamis. Okay, and that's very interesting, because instead of talking about bedrooms or dining rooms, etc., they talk about tatamis, and instead of talking about square meters, they talk about tatamis, because the tatami is related to the human scale. So it's not the square meters, that is something abstract. No, tatami is related to a human position on the floor for one person. That's all. No, so all the space is defined through the human scale, human dimension. And the spaces is like adding people, no, in some way. And they are undefined because you can use the same place for dining, midday, or sleeping at night. And this is what I think that is very interesting, because it's undefined, but at the same time defined by the human dimension. No? And the other thing that I think is very nice is that it transmits always the idea of lightness, because it works by layers. No, instead of working by massiveness, it works by layers. No, and it's very famous this space, the Engawa. No, Engawa is this threshold, no, in between inside outside. No, and then it's always being very so it diffuse, or it is this very very well inserted in the landscape, or in the urban or natural landscape, even maintaining its own character, no? Its own personality. Because I think that this kind of layering, no? This idea of approaching this layering is very interesting. Or even there's always a room that is in the same level of the street. There is the place that you leave the shoes. And then is when you move up to the house, no? Or even when you go up to a second level, the first step is a stone. So the stairs are not directly connected to the sky. The first step is connected to the earth, to the ground, and the second one is connected to the sky. No, so it's very like it's very related to, with this idea of lightness, is very related to the sky, but sometimes it's very like it's promoting roots to the land, no, in some way. I think it's very interesting how it's defined. That means that it's suggesting constantly how to inhabit, instead of imposing how to inhabit them.
Okay, we have one more question and then wrap things up, but it's coming from Shahrokh, and he's asking both of you, but it might be more in align with Josep, but how much have new methods of like digital fabrication, CNC, affected your projects, if any, or has there been no need for new methods, new technologies like that?
I used to work in a very handmade parametric system. So I used to work a lot, as you see, with, well, there are some wheels here, you see, no? Some of the wheels, some of the models of the wheels, and these are some sketch models to understand the geometry of the wheel, to understand how the same piece could be a radius system or a circumference system, only changing 8 times the angle with the same pieces, the same diamonds. No, so I think that I think it's interesting to work with this idea of parametric conditions, but never understanding that the tools or the new tools are like imposing to you what you are able to make. So I think that it's important is to think by sketch models, whatever, no, and then to understand or to use these new tools in order to understand the possibilities of variations of this, but not just the opposite. No, not working with these new tools. It's a way of imposing you the limits of what you think. So I believe in that things, but not only as a tool.
And what about you, Marcos?
Ferramentas. Ferramentas. Veja, eu tenho agora em andamento, eu tenho um conjunto habitacional grande para a Prefeitura de São Paulo. Terreno de 45 mil metros quadrados, tem 2 prédios já feitos em alvenaria de bloco de concreto, que é um sistema construtivo muito interessante. Eu trabalho com bloco de concreto desde sempre. A primeira obra que eu fiz foi com bloco de concreto, em 1965, era estudante ainda. Fiz uma casa para o meu tio de bloco de concreto. Soube que ela está ótima até hoje, está em excelentes condições. Estou fazendo, então, esse conjunto habitacional grande, bloco de concreto, alvenaria armada de bloco. A previsão era 1.300 apartamentos para favelar. E para enfrentar uma obra desse tipo, evidentemente, eu não teria como realizá-la com madeira. Desse volume, eu não teria quem fornecesse componentes de madeira suficientes para atender essa demanda. Então, a solução mais corrente, mais econômica que nós temos é bloco de concreto. Tem 2 edifícios já prontos, alvenaria armada de bloco de concreto, paredes portantes, etc. E tal. E 2 edifícios subindo agora, mais altos, com estrutura de concreto e fechamento em bloco de concreto. Tem um edifício de apartamentos também de estrutura de concreto, 120 apartamentos pequenos, de 30 metros quadrados, 12 andares. E tem essa casa, está para começar, uma casa com que a estrutura final acabou sendo de aço, por conta de uma série de questões de ordem técnica. Quer dizer, a coisa dos sistemas, para mim, é uma coisa aberta. Eu não trabalhei muito tempo com madeira, mas não só com madeira. Mas essa obra aqui ia ser de madeira, que não foi, que virou para aço, por uma série de circunstâncias técnicas, seria uma obra de madeira faz algum tempo que eu não faço. Ela tem, na verdade, um componente, uma pérgola de madeira sobre uma piscina, que eu estou fazendo, e vai ser a minha primeira obra em laminado polar. Incrível. Todas as obras que eu mostrei, essas obras que eu mostrei na apresentação, são de essência nativa, de manejo sustentável, que vieram da Amazônia. Eu não fiz ainda nenhuma obra com laminado polar, feito pela ITA, construtora. Quer dizer, são circunstâncias, às vezes, profissionais, das demandas que a gente tem, a gente não decide por esse ou aquele sistema, esse ou aquele componente. Tem uma série de outras questões que são, às vezes, que a vida traz para a gente vai tendo que enfrentar. Provavelmente, eu espero que eu venha trabalhar com alguma coisa moldada parametricamente, a partir de modelagens novas, essas modelagens novas. Espero que sim. Esse concurso da Antártica tinha esse caráter, mas é um projeto de concurso que não foi escolhido. Incrível, deixa eu só comentar. Havia, evidentemente, nesse concurso, muitos projetos de madeira, mas eu soube que havia no júri 2 arquitetos da Marinha Brasileira e que disseram desde o início, olha, a Marinha Brasileira não tem prática de fazer manutenção em madeira. Nós temos prática de fazer manutenção em aço. Então, os projetos em madeira já foram um pouco colocados de lado. De fato, entre os projetos premiados todos, não tem nada de madeira. Bom, isso.
That's too bad. But anyways, thank you, Marcos. Thank you, Josep. I think that wraps up the program. So it was a pleasure. I guess we'll go
Thanks
back
to
to
you, John. Thanks to you, John, for this kind of conversation. And muito obrigado, Marcos, pela sua arquitetura.
So I would also like to thank you very much, Josep, Marcos, and John, for this very insightful presentation and conversation. This was the last edition of the Future Now webinar series. As a wrap-up, we will publish and send out in a week or so an exclusive written interview with Marcelo Aflalo from Brazil and Diego Balayan from Chile about ephemeral wood constructions. The exhibition at the Mauá Square will close also next Sunday, October 17th already. However, we are about to look for a new home for the pavilion somewhere in São Paulo later this year or in 2022. Please find more information about the Future Now Pavilion, the exhibition at our website, insight-architecture.com. There you also can subscribe to our newsletter to keep being updated about the Pavilion and the Future Now initiative. So thank you again, everybody, for participation and watching. Bye-bye.